Welcome back to geometry class. Today is Friday and we're working on 10-5 tangents. A tangent is a line in the same plane as a circle that intersects the circle at exactly one point. A line in the same plane as a circle that intersects the circle in exactly one point. So basically it's a line in the same plane as a circle, intersects the circle at one point. So here's an example of a line that's intersecting a circle at one point. Everybody got it? So here I have circle C is intersecting at one point A, and that point is actually called my POT. I just abbreviate it. I always call it my pot. What is POT? That's the point of tangency. So the point of tangency is that one point where the tangent intersects the line. So the point of tangency is that point where the line intersects the circle. Everybody got it? Common tangent is a line, ray, or segment that is tangent to two circles. A line, ray, or segment that is tangent to two circles. So they kind of have a tangent line in common. So for example, and y'all know my drawing is bad, if I had a circle, and I'm kind of draw the other line, a point of tangency is meeting right there, intersecting at one line. And if I had another circle, so see I have two circles, and assume my line's straight. Oh, my line actually is pretty straight. So it's two circles and they have a tangent in common, a line in common that intersects both of them. Got it? Another way we could do it is like two circles, and if I had a line going through it, and so that would be the point of tangency. And so they have a line that has that's in common with the two circles. Got it? Alright. So we're going to come to the next one. Ignore this. That's just a piece of paper that copied wrong on the paper. So that's not a line or anything that has to do with the paper. Got it? The first theorem says, in a plane, a line is tangent to a circle in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to a point of tangency. So in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. And so here's an example of that right here. Line L is the tangent line, and it's tangent to circle S. And so it's showing that the radius is perpendicular to that point of tangency. So from the radius to that point of tangency, which is point T. Got it? Okay, so let's look at an example. Some examples. Let me get both of them on the screen. All right. Example 2 says JL is a radius of circle J. Determine whether KL is tangent to circle J. Justify your answer. So we see that that radius and that tangent line KL, all of that is forming a triangle, right? So we want to test to see if it is a right triangle, because if it's a right triangle, remember from the radius to the tangent line, it's supposed to be perpendicular, right? So if we do the Pythagorean theorem, we would have 15 squared plus 8 squared is supposed to be equal to 9 squared, right? And so 15 squared, we know that's 225 plus 64, and oh, you know what? I'm not paying attention. This 9 is only on the outside. So remember radii all the same, right? So from here to here, the JL is 8. So that means from J to that point, that's also 8. My bad, I didn't pay attention. I just saw 9 and wrote it. 9 is only the outside segment. Everybody got it? So 9 plus 8, this is actually supposed to be equal to 17 squared. Got it? And so 17 squared is 289. 225 plus 264 is also 289. So is this a right triangle? Yes. So that means that it is. Radius is perpendicular to that tangent line. So it is justified. Everybody got that? All right, let's look at another example. Oh, and you can see both of them the same thing. It says JH is tangent to circle G at J. Find the value of X. So let me take a moment to look at what I'm given. We see our radius is unknown, X and X. We have our tangent line, HJ, which is worth 12, and an exterior, KH, is worth 8. So if we did the Pythagorean theorem, we would end up with x squared plus 12 squared is equal to x plus 8 squared. I see we're getting a little algebra in here. We know x squared plus 12 squared is going to be 144. Don't forget, what does x plus 8 squared mean? It means you write it twice. It's to the quantity squared. And now we're going to factor it. So we have x squared, 8x and 8x is 16x, and 8 times 8 is 64. And I need to bring everything else down. And let me scoot this up a little bit. And so from here we just solve. Don't worry, Victoria, I know you're sighing because every time we say algebra you sigh. It's going to be easy. We subtract x squared on both sides. Cancels. Subtract 64 on both sides. And we're left with 16x equals 80. Divide by 16. And x equals 5. And so there we were able to find our value of x. If you have any questions or you think you're lost, just pause. Pause for the cause. Okay, sorry. And let's look at the back. Speaking of pause for the cause, I need to go get something to drink. Hold on, I'll be right back. Alright, so our next theorem says if two segments, you know I abbreviate everything, from the same exterior point are tangent, So two segments from the same. Ooh, I'm writing a line going up. Okay, who cares? Two segments from the same exterior point are tangent to a circle. Then, draw my little then arrow, they are congruent. So if two segments from the same exterior point are tangent to a circle, then they're congruent. Pretty easy. So this is what it's showing. So see, we have a circle, right? We have two tangent lines. We have a tangent line from A to B. There's a tangent line from C to B, right? So those two tangent lines both share that same exterior point of B, right? So that means those two tangent lines are congruent. That's all it's saying. So when you look at example 3, you know we're going to do some more algebra. It's an easy one-step problem. It says find x, assume the segments that appear to be tangent are tangent. Why do we say that? Because in some cases like this, some people's brains want to say, I know Hannah, first period. I know you're thinking, you probably said this question out loud. If you look at it, to me, it looks like you kind of can draw the line straight through, so it wouldn't be a tangent line, it'd be more of a secant line. So that's why it says to assume it's tangent. So it's only intersecting at one point, but some people want to say, oh, well, if we bring it right through, it's not tangent, it's secant. So in some cases, they'll tell you to assume it's tangent. So just be careful with that. So we see that BC and CD are tangent, and they share that same exterior point of C, right? So that means that these two are going to be congruent. So we have x plus 3 equals 7. Subtract 3 on both sides, and x equals 4. Is that all we're supposed to do? Yep. Just finding x. Got it? Alright. Let's come down to our last one. Let me try and fit all that. Oh, y'all can see my little tripod. Oh, now you can see it again. Who cares? Alright. Last one, circumscribed polygons. So we talked about circumscribed polygons in the last lesson. I think the lesson before last. And so remember, it just means that you have a polygon that's on the interior and all the vertices. Well, it's a circle, so it's not vertices, but they're touching it. So when a polygon is circumscribed I'm talking about inscribed, to be inside. We're talking about circumscribed, so it's from out or in. When a polygon is circumscribed about a circle, all the sides of the polygon are tangent to the circle. So all that means is that it touches it at a point, that point of tangency. So all those lines are tangent to the circle. A graphic designer is giving directions to create a larger version of the triangular logo shown. If triangle ABC is circumscribed about G, circle G, find the perimeter of triangle ABC. Alright, hold on, I need to take a second to look at this and digest it. Okay, so remember that it says a circumscribed polygon that all the sides are tangent, right? And so with our rule, it says that if tangent, if two segments from the same exterior are tangent, then they're congruent, right? So if we look here, we have AD and AE. They're tangent to that circle logo, right? Because they both share A. So if this side's 8, that means this side is also 8. Got it? Let's look at another one, and I'll do squiggly lines. So this one and this one are both tangent to the logo, and they share B, right? So if this is 7, that means FB is also 7, right? And on this one, we don't know those, but we know that the entire side's 10. So if we do 10 minus 7, that means CF is 3. And CF and DC share C. So if that's 3, that's also 3. And so, of course, to find the perimeter logo, We had 8 plus 8 plus 3 plus 3 plus 7 plus 7. 7 and 3 we know is 10. 10 that's 20 plus 8 that's 36. And so that's the perimeter triangle, and that sums up tangents.